December 17th, 1944. Skies above the North Sea. The radio operator's pencil hovered over his log sheet as the clock ticked past 1400 hours. 23 dots had been moving steadily across his scope just moments before. Now only 18 remained. 5 B-17 flying fortresses from the 91st Bomb Group, carrying 50 men and 60 tons of military hardware, had vanished from radar coverage in less than 30 seconds. No distress calls, no indications of enemy contact. The massive aircraft had simply disappeared into the towering wall of clouds that stretched from 2,000 feet to over 35,000 feet along the bomber stream's return path from Bremen. Lieutenant Raymond Carter at RAF Ridgewell Control Tower reached for his microphone. "Bluebird leader, this is home plate. Be advised weather system intensifying at your 2 o'clock. Recommend immediate diversion to heading 090. His voice betrayed no emotion, though his knuckles whitened around the microphone. The acknowledgement came back garbled, barely audible through the static. Then silence. 3 more radar returns faded from his screen. That afternoon, 8 complete bomber crews would fail to return to their bases across East Anglia. None had reported enemy fighters. None had reported flak damage. Post-mission analysis would attribute all losses to a previously undetected cold front that had developed with catastrophic speed into a massive line of cumulonimbus formations containing vertical wind shears exceeding 100 miles per hour. The phenomenon was not unprecedented. Since the commencement of daylight strategic bombing operations in 1942, meteorological officers had documented 147 aircraft losses directly attributable to severe weather encounters. What perplexed commanders was the seeming deliberateness with which crews sometimes approached these aerial killing grounds. Veteran pilots with dozens of missions, men who had survived the fiercest flak over Berlin and fought off waves of Luftwaffe interceptors, were somehow falling victim to weather patterns that training dictated they should avoid at all costs. Colonel James Harrison, commanding the 398th Bombardment Group, had first noticed the pattern in November 1943. Reviewing mission debriefs at Nuthampstead, he identified 17 separate incidents where experienced pilots had deliberately penetrated thunderstorm cells rather than executing standard avoidance procedures. "These weren't green kids straight from training," Harrison later wrote in his post-war memoir. "These were combat-hardened crews who knew better. Something was happening up there that we weren't understanding." By early 1944, the 8th Air Force was losing an average of 3.8 aircraft per week to severe weather, a rate that translated to 197 aircraft and nearly 2,000 airmen annually. These losses represented 12% of all operational aircraft losses, a figure that stunned commanders when Harrison's analysis reached 8th Air Force headquarters. The strategic implications were profound. Every bomber lost meant reduced striking power against German industrial targets. Every experienced crew lost meant replacing them with novices who required 5 to 7 missions before achieving comparable combat effectiveness. More disturbing was the realization that these losses were largely preventable. 8th Air Force Weather Section analysis showed that in 76% of weather-related incidents, sufficient meteorological information had been available to predict dangerous conditions. In 82% of cases, the aircraft had viable alternative routes that would have avoided the worst conditions. Yet crews consistently chose the direct path through clouds rather than deviating around them. The visual phenomenon became known to controllers as cloud swallowing. One moment, a formation would be visible on radar, tracking steadily. The next, aircraft would enter cloud masses, and radar returns would begin blinking out one by one, like lights being systematically extinguished. What compelled experienced airmen to violate their training and fly directly into weather that could tear their aircraft apart? The answer lay in a complex matrix of technical limitations, psychological factors, and battlefield realities that would take months to fully understand, and cost hundreds of lives before effective countermeasures could be implemented. As Colonel Harrison noted in his final report of February 1945, "When we send men to face bullets and flak, we accept certain losses as inevitable. But no strategic objective justifies losing aircraft to weather. These are airmen who have survived 20-25 combat missions over the most heavily defended targets in Europe, only to disappear into clouds from which they should know to stay clear." Something fundamental is happening in those cockpits that we have failed to address in our training and procedures. The thunderstorms over Europe were about to reveal themselves as adversaries more implacable than any human enemy, and the lessons learned would come at a terrible price. The Boeing B-17G Flying Fortress, fully loaded for combat operations, weighed 65,500 pounds, 32.75 tons of aluminum, steel, glass, rubber and flesh, suspended 7 miles above the Earth through the complex interaction of 4 Wright R-1820-97 Cyclone 9-cylinder radial engines generating 1,200 horsepower each. The mathematics of flight that kept these massive machines aloft were precise and unforgiving. At cruising altitude of 25,000 feet, each square foot of wing surface supported 30.82 pounds of aircraft weight. The structural limit for positive G-forces was 5.0. Beyond this threshold, wing spars would begin to deform and ultimately fail catastrophically. What meteorologists now refer to as cumulonimbus incus, the classic anvil-topped thunderstorm, creates an atmospheric environment that systematically exceeds these tolerances. Updraft velocities within fully developed thunderstorm cells over continental Europe regularly exceeded 5,000 feet per minute. An aircraft encountering such vertical currents would experience instantaneous acceleration exceeding 2.5 VEGs, half the B-17's structural tolerance. Alternating updrafts and downdrafts could subject the airframe to rapid oscillations between positive and negative loading, creating metal fatigue in critical structural components. Air Force Meteorological Officer Captain Richard Whitcomb conducted post-incident analysis of the December 17, 1944 storm system that had claimed 8 bombers. His report, filed January 8, 1945, documented atmospheric conditions far exceeding these averages. Barometric pressure differentials within the cell indicate vertical air velocities approached 9,800 feet per minute in localized columns. Aircraft encountering these conditions would experience forces exceeding 4G, potentially approaching structural limits when combined with turbulence-induced vibration. The German FW-190 fighter pilot Otto Koenicke, captured in March 1944, provided unexpected insight during interrogation at Camp Fort Hunt, Virginia. "We were taught to avoid pursuing bombers into cumulus formations," Koenicke stated through an interpreter. "Our aircraft weighed 4.3 tons fully loaded, less than a quarter of the B-17. Even at this weight, instructors warned us thunderstorms could tear the wings off our fighters. We watched an American bomber formation enter clouds over Hamburg. When they emerged, 2 were missing. No pilot shot them down. The weather claimed them." Beyond structural stresses, thunderstorms created electrical environments capable of disabling critical navigation and communication systems. Lightning strikes, while rarely fatal to the aircraft itself, could destroy radio equipment, compass systems, and electrical generators. Technical Sergeant James Forrest, radio operator on a B-24 Liberator that survived a thunderstorm encounter over the Adriatic Sea on March 8, 1944, reported in his post-mission debrief, "The strike entered through the nose, travelled along the main electrical bus, and exited through the tail. All 4 compass systems failed simultaneously. Radio equipment was completely disabled. The pilot reported temporary blindness from the flash. We navigated the remaining 340 miles by dead reckoning, arriving over base with less than 30 gallons of fuel remaining. Ice accumulation presented an equally lethal threat. At altitudes between 8,000 and 22,000 feet, Thunderstorms contained supercooled water droplets that instantly froze on contact with aircraft surfaces. A B-17 flying through these conditions could accumulate up to 6 inches of ice on leading edges within 15 minutes, adding 2,800 pounds of weight while simultaneously decreasing wing efficiency by 30%. This combination reduced ceiling height by approximately 4,000 feet and increased stall speed by 14 mph. Under maximum combat load, this degradation left pilots with a safety margin of just 18 mph between cruise speed and catastrophic stall. The instruments available to 1940s bomber crews were critically inadequate for thunderstorm penetration. The standard artificial horizon in the B-17G could only display pitch attitudes to plus and 60 degrees. In severe turbulence, the gyroscopic system could tumble, becoming completely unreliable. Rate of climb indicators lagged actual vertical speed by 6 to 8 seconds, an eternity when encountering 5,000 foot per minute updrafts. In conditions of zero visibility, with unreliable instruments and aircraft approaching structural limits, crews faced what flight physiologists termed spatial disorientation cascades, a progressive deterioration of situational awareness leading to control inputs that exacerbated rather than corrected dangerous attitudes. Lieutenant Colonel Michael Hannigan, who studied the wreckage of a B-17 that crashed in Scotland after weather encounter on January 30th, 1944, documented the mechanical evidence of this phenomenon. Control surfaces showed full deflection at impact. The aircraft struck the ground in a 70-degree spiral dive with engines at maximum power. Analysis of the flight control cables indicates the pilot was applying full opposite controls at impact, suggesting he believed he was correcting a spin in the opposite direction. Classic spatial disorientation scenario. The United States Strategic Air Force's statistical branch calculated that a B-17 entering a fully developed thunderstorm had a 22% chance of encountering conditions exceeding structural limits or crew capabilities. The probability of 2 consecutive storm penetrations without major damage or crew incapacitation fell to just 6%. Yet bombers continued to enter these aerial minefields, often with crews fully aware of the statistical death sentence they were facing. The question remained, why? The rapid expansion of the Army Air Forces from 1941 to 1943 created a training pipeline focused on quantity over depth. When Pearl Harbor thrust America into global conflict, the entire USAAF possessed only 12,297 aircraft and 45,000 personnel. By December 1943, those figures had exploded to 64,232 aircraft and 2.4 million personnel, a growth rate of 522% for equipment and 5,233% for personnel in just 24 months. This unprecedented expansion necessarily compressed training cycles and eliminated specialized instruction that would later prove critical. Flight Cadet Howard Richardson entered flight training at Maxwell Field, Alabama, in January 1942. His complete meteorological training consisted of 14 classroom hours, focused primarily on basic cloud identification and altimeter corrections. Weather avoidance was covered in a single 3-hour lecture, Richardson recalled in a 1947 interview with Army Air Force's Historical Division researchers. The instructor basically told us to stay away from thunderstorms and emphasized that weather flying required instruments we hadn't yet been trained to use. Most of us had never seen the inside of clouds before receiving our wings. The 1943 AAF training manual, Weather Flying for Multi-Engine Pilots, contained just 6 paragraphs on thunderstorm avoidance, with the primary guidance being, never enter a thunderstorm if avoidable, circumnavigate or turn back rather than penetrate. Nowhere in the 148-page document were techniques for emergency thunderstorm penetration discussed. Flight instructors across training commands developed an informal motto: if you can see it, don't fly into it. If you can't see it, assume it's there. By contrast, commercial airlines had developed comprehensive thunderstorm penetration protocols years before the war. Transcontinental and Western Airlines, TWA, Captain Ernest Gann, who later joined the Air Transport Command, documented the disparity in his flight logs. Civilian operators recognized severe weather as our primary threat. Military training treated weather as an inconvenience rather than a lethal adversary. This fundamental difference in perspective would prove costly when military operations couldn't simply cancel flights due to forecast conditions. Lieutenant James Whitaker, one of the few AAF pilots to receive specialized instrument training before deployment, noted the statistical consequences in his March 1944 report to 8th Air Force Headquarters. Approximately 82% of weather-related incidents involve pilots with fewer than 50 hours of actual instrument flying time. The average B-17 pilot arrives in theater with 12.4 hours of instrument time, primarily in trainers substantially more forgiving than fully loaded bombers. This experience deficit represents a critical vulnerability. The institutional focus on enemy action further diminished attention to weather threats. Early mission debriefing forms contained 16 questions regarding enemy fighter tactics, but only a single line for weather conditions encountered. The standardized after-action report format dedicated 3 pages to flak patterns and fighter engagements, but only 2 lines to meteorological observations. This reporting imbalance created an institutional blind spot. Weather-related near misses went largely undocumented and unanalyzed until catastrophic incidents forced attention. Captain William Foster, meteorological officer for the 100th Bombardment Group, documented this pattern in his January 1944 assessment. Loss of 3 aircraft from the 351st last week has been attributed to operational accident rather than engaging with the actual cause. Inadequate weather forecasting and avoidance training. We continue treating weather as an administrative matter rather than a tactical threat comparable to enemy action. The navigational and forecasting technologies available further compounded these vulnerabilities. The accuracy of 12-hour weather forecasts for northwestern Europe in 1943 barely exceeded 58%, according to post-war analysis by RAF Meteorological Research Command. Radio direction finding equipment relied on ground stations with limited range and accuracy beyond coastal areas. Radar sets, when available, were primitive by later standards, with no ability to distinguish between precipitating and non-precipitating clouds. Cloud heights could only be estimated by visual observation during daylight hours. On March 3, 1944, Lieutenant Colonel Robert Terrell, operations officer for the 96th Bombardment Group, documented a catastrophic mission outcome stemming directly from these limitations. Mission 241 to Berlin encountered unexpected weather front at 53 degrees 8 degrees. Forecast called for scattered cumulus, 3x10 coverage, tops at 15,000 feet. Actual conditions included embedded cumulonimbus formations extending to 38,000 feet. Lead Navigator had received 6 total hours of weather avoidance training. Formation attempted to climb over system rather than diverting 60 miles north, as SOP now dictates. 3 aircraft lost, no survivors, no enemy contact reported. By early 1944, the cumulative impact of these incidents finally penetrated command consciousness. General James Doolittle, assuming command of 8th Air Force in January 1944, identified weather-related losses as a critical vulnerability requiring immediate intervention. His February 7, 1944 directive to all group commanders stated plainly, "We are losing too many aircraft and crews to weather. This is unacceptable. Every weather loss represents a failure of training, procedure, or command judgment. Effective immediately, weather avoidance will receive priority equal to target acquisition and enemy defense penetration in all planning and execution phases." The directive came too late for hundreds of airmen already lost to the invisible killer lurking in European skies. But more critically, it failed to address the fundamental question: Y were experienced crews who had survived multiple combat missions and witnessed the lethal consequences of weather penetration, still flying into clouds they should have known to avoid at all costs. April 11th, 1944. 29,000 feet above Stettin, Germany. Captain Michael Harrington of the 303rd Bombardment Group faced a decision that would determine whether his 10-man crew lived or died. Their B-17F Carolina Princess had completed its bombing run and turned west toward England when forward visibility deteriorated rapidly. A massive wall of cumulonimbus clouds extended from 12,000 to 38,000 feet directly across their return path. Radio calls confirmed the weather system stretched over 140 miles north to south. Fuel state after the extended mission showed 680 gallons remaining, sufficient for 3.4 hours at cruise power. A 175-mile diversion around the storm system would consume an additional 110 gallons, reducing their reserve to just 32 minutes upon reaching the English coast. Harrington's decision to penetrate the cloud formation rather than divert became the subject of intense analysis when Carolina Princess miraculously emerged on the western side with severe structural damage but no casualties. The aircraft landed at RAF Woodbridge Emergency Field with a 6-foot section of right wing missing, radios inoperative, and the navigator suffering a broken collarbone from extreme turbulence. The subsequent investigation revealed a decision-making pattern that would be documented in 72% of similar incidents between January and October 1944. The mathematics of survival shifted fundamentally once we crossed enemy territory, Harrington explained in his debriefing. Every mile of diversion extended our exposure to flak belts and fighter coverage. The storm represented a 22% probability of aircraft loss, according to the statistics we'd been given. German fighters represented a near 100% probability of interception if we remained over hostile territory for an additional 40 minutes. When viewed through this lens, flying into the clouds became the rational choice, despite the known dangers. This combat calculus, weighing certain danger against probable danger, became known as Hobson's choice among bomber crews. 8th Air Force Operational Research Section documented this phenomenon in their August 1944 report titled Weather Penetration Decision Factors in Combat Operations. The report analyzed 118 incidents where crews chose to penetrate known hazardous weather rather than divert. In 84% of cases, mission parameters had created conditions where all available options carried significant risk of loss. The air crews simply selected what they perceived as the least lethal alternative. Radio transcripts from the 95th Bombardment Group mission to Merseburg on September 28, 1944, provided stark illustration of this decision process. At 14:22 hours, the formation lead aircraft transmitted, "Command to all ships, weather system ahead, visibility 0, tops above our ceiling, estimate 60 miles deep, fuel state critical. Alternative routing adds 40 minutes exposure in known fighter alley. We are proceeding straight ahead. Aircraft unable to maintain formation should descend to Angels 15 and proceed independently to Rally Point Delta." Of the 21 aircraft that entered the cloud formation, 17 emerged on the western side. 4 disappeared from radar and were never heard from again. No distress calls were recorded. Post-mission analysis estimated the formation encountered vertical shear forces exceeding 7,000 feet per minute within the cloud mass, sufficient to exceed structural limits of aircraft already weakened by flak damage from the target area. The command structure compounded these impossible choices. Lieutenant Colonel James Thornton, operations officer for the 91st Bombardment Group, documented this pressure in his private correspondence dated July 17, 1944. "Today, I sent 23 crews into weather I wouldn't fly into myself on a clear day with a new aircraft. The mission requirements didn't change despite the forecast. The target had to be hit. The generals demand results, not excuses about clouds. When formation leaders request weather diversions, The response from division inevitably questions whether they have the nerve for the job. So they press on, directly into conditions everyone knows are potentially lethal. The psychological impact of combat fatigue further distorted risk assessment capabilities. Dr. Samuel Thompson, flight surgeon attached to the 379th Bombardment Group, documented decreasing risk aversion among crews approaching the end of their combat tours. Pilots with 20-plus missions demonstrate measurably impaired decision-making regarding weather risks. Having survived flak and fighters repeatedly, they develop an irrational confidence in their aircraft's durability and their own skill. Simultaneously, they become hyper-focused on completing their required missions to rotate home. This combination makes them more likely to attempt weather penetration rather than accept a mission scrub that would extend their combat tour. Captain William Reeves, one of the few pilots to refuse a weather penetration despite direct orders, described the resulting command reaction in his service record appeal. After turning the formation around rather than entering a severe storm front over Hamburg, I was relieved of command and assessed as lacking necessary aggressive spirit. 3 aircraft from another group penetrated the same system. None emerged. Their loss was attributed to operational hazards rather than command pressure to continue regardless of conditions. Statistical comparisons solidified the final grim mathematics. Between June 1943 and May 1944, 8th Air Force bomber units lost 1,872 aircraft to enemy action, flak, fighters, and ground fire combined. During that same period, 289 aircraft were lost to documented weather-related causes, representing 13.4% of all operational losses. However, the average crew survival rate for enemy action was 37%, with most losses including at least some parachute escapes or crash survivors. For weather-induced crashes, the survival rate was just 4.8%. Weather didn't just destroy aircraft, it killed entire crews with devastating efficiency. By late 1944, the pattern had become clear to analysts, if not to commanders. Bomber crews were flying into clouds because the alternatives often seemed worse. The path through the storm, however deadly, appeared to be the shortest road home. The solution would require fundamental changes in technology, training, and tactical doctrine that many senior officers initially resisted acknowledging. November 18, 1944, marked the turning point in the 8th Air Force's battle against the invisible enemy that had claimed more lives than the Luftwaffe's elite fighter units. General Jimmy Doolittle, reviewing the devastating October weather losses, 27 aircraft and 270 men in a single month without firing a shot at the enemy, issued Operational Directive 4428, a 4-page document that fundamentally transformed weather protocols across all bomber commands. "We have been fighting this war with half our attention on the enemy and almost none on the environment," Doolittle wrote in the directive's opening paragraph. "Effective immediately, meteorological considerations will hold equal priority with tactical objectives in all mission planning and execution." The directive initiated a comprehensive overhaul of equipment, training, and procedures developed by a specialized task force led by Colonel Edward Brooks, former TWA Chief of Meteorological Operations. Brooks assembled a team of 14 civilian airline pilots, 8 meteorologists from the National Weather Service, and 12 combat-experienced bomber pilots to develop what became known as the Strategic Weather Avoidance Program, SWAP. The technical improvements came first. By December 1944, every lead aircraft in bomber formations received the AN/APS-15 radar system with its distinctive H2X Mickey radome mounted in the aircraft's belly. Originally designed for bombing through overcast, the radar's 3-centimeter wavelength could detect precipitation within storm cells at ranges up to 90 miles. Operators received specialized training in distinguishing between stratiform precipitation and convective cells with 93% accuracy in controlled tests. Simultaneously, the Material Command expedited delivery of improved gyroscopic instrumentation. The A-12 Artificial Horizon replaced the standard J-8 model, providing attitude indication through a full 360 degrees of pitch and roll without tumbling, critical for recovery from extreme unusual attitudes encountered in severe turbulence. By February 1945, 76% of 8th Air Force bombers had received this vital upgrade. Training underwent equally dramatic revision. The 11-day weather course established at Alcombri in December 1944 became mandatory for all lead crews. Captain Richard Harworth, the program's lead instructor, implemented simulation exercises using aircraft mounted on hydraulic platforms that could replicate severe turbulence conditions. Pilots learned to trust their instruments implicitly while experiencing physical sensations that contradicted what the gauges were telling them. Hayworth explained in his post-war analysis, "We created conditions where their senses lied, but their instruments told the truth. It was the only way to overcome the instinctive responses that had been killing crews." The procedural changes proved equally significant. The most controversial was Directive 4439, implemented January 15, 1945, which fundamentally altered the command structure for weather-related decisions. Formation leaders received absolute authority to divert around weather without higher approval, removing the pressure to press on regardless of conditions. More importantly, the directive prohibited any negative performance assessment for weather diversions, eliminating the career concerns that had pushed commanders to take unnecessary risks. February 22, 1945, provided the first major test of these new systems and procedures. The 381st Bombardment Group, returning from Leipzig with 34 B-17Gs, encountered a rapidly developing frontal system extending from Belgium across the North Sea. Using H-2X radar mapping, Major Thomas Willingham, commanding the lead aircraft, identified a severe squall line with embedded thunderstorms extending 175 miles across their return path. Pre-swap protocols would have forced a direct penetration due to fuel considerations. Instead, Willingham implemented the new weather avoidance procedures. Command to all aircraft. Weather system ahead extending Angels 10 through Angels 35. Implementing Swap Protocol 3. Lead squadron will descend to Angels 8 and proceed on heading 270. High and low squadrons offset 3 miles north and south respectively at Angels 6 and Angels 10. Maintain visual separation from cloud bases. Reassemble western side of system for channel crossing. The formation successfully navigated beneath the weather system, maintaining visual contact with the ground while avoiding the lethal updrafts and downdrafts that had claimed so many aircraft before. All 34 aircraft returned safely to base despite the additional 60 miles added to their route. The mission debriefing became a textbook example distributed throughout 8th Air Force bomber groups. Statistical analysis confirmed the program's effectiveness with devastating clarity. Between January and April 1945, weather-related losses decreased by 78.3% compared to the same period in 1944, despite similar meteorological conditions and increased operational tempo. The 100th Bombardment Group, which had lost 14 aircraft to weather between September 1943 and September 1944, recorded 0 weather-related losses after implementing the swap protocols. Overall, 8th Air Force weather-related losses fell from 13.4% of total losses to just 2.9% during the program's first 3 months. Colonel Brooks, addressing the Joint Weather Analysis Conference in July 1945, summarized the transformation. "We were losing bombers because we treated weather as an administrative inconvenience rather than a tactical problem requiring tactical solutions. Once we applied the same analytical rigor to weather that we applied to enemy defenses, the solutions became obvious. The physics of thunderstorms hadn't changed. Our approach to them had." The most poignant testimony came from Captain Michael Harrington, whose harrowing experience penetrating clouds in Carolina Princess had contributed to the program's development. Leading a formation of B-17s returning from Dresden on March 2, 1945, Harrington encountered weather conditions almost identical to those he had faced 11 months earlier. This time, equipped with H-2X radar and operating under SWAP protocols, he diverted his formation 80 miles south, adding 37 minutes to their flight time, but avoiding the severe weather system entirely. The difference was night and day, Harrington wrote in his mission report. Last April, I had to choose between likely death from fighters if I diverted and possible death from weather if I penetrated. This time, I had the information, the authority, and the procedures to make the correct choice without sacrificing the mission or the aircraft. We returned with 36 aircraft intact and 360 men alive. 11 months ago, that outcome would have been impossible. The final accounting of weather-related bomber losses during World War II revealed a sobering statistical reality. Between August 1942 and May 1945, the 8th Air Force lost 387 heavy bombers and 3,483 airmen to documented weather incidents. When including aircraft missing without explanation over non-combat areas, the total climbed to 432 aircraft and approximately 3,900 men. The United States Strategic Bombing Survey, published in September 1945, concluded that 14.2% of all operational heavy bomber losses resulted from weather encounters rather than enemy action. The human toll exceeded the total combat deaths suffered by 3 infantry divisions during the entire European campaign. First Lieutenant David Thatcher, navigator on B-17G Blind 8 with the 452nd Bombardment Group, survived when his aircraft broke apart at 27,000 feet after entering a severe thunderstorm over the North Sea on January 8, 1944. Thrown clear during structural failure, Thatcher deployed his parachute and landed in the frigid waters, spending 11 hours in a life raft before rescue by a British air-sea rescue launch. He was the sole survivor from a crew of 10. His final navigation log entry, recovered from the wreckage, read simply, 1442 hours. Severe turbulence. All instruments unreliable. Compass spinning. God help us. Thatcher's testimony at the Strategic Air Operations Conference in August 1945 provided closure to the institutional questions that had plagued bomber operations throughout the war. We entered the clouds because we had completed 24 missions, Thatcher explained. The mathematics were simple. One more successful mission meant rotation home. Diverting meant potential abort, another mission tomorrow. The storm seemed like the shorter path to survival, despite everything we knew about the risks. Combat doesn't breed rational decision-making. It breeds desperation. This psychological insight proved as valuable to post-war aviation as the technical solutions developed through the Strategic Weather Avoidance Program. When Pan American World Airways established its Atlantic Division in 1946, staffed largely by former military pilots, the airline implemented a radical departure from military protocol. Chief Meteorologist Leonard Wells, who had served as Deputy Weather Officer for 8th Air Force, created the Crew Decision Matrix, which removed all negative consequences for weather-related diversions or cancellations. The lessons from bomber operations influenced every aspect of our procedure development, Wells noted in his 1953 memoir, Weather and Wings. We learned that pilots will take irrational risks when organizational pressure creates incentives to continue regardless of conditions. Our philosophy became simple. No flight schedule is worth a single human life. We would rather delay every flight in our system than create conditions where a crew feels compelled to penetrate weather they would otherwise avoid. The technical legacy proved equally significant. The AN/APS-15 radar system developed for bomber weather avoidance evolved into the first generation of commercial weather radar sets. The RCA AVQ-10 weather radar, standard equipment on airliners by 1956, traced its design lineage directly to the military system. The operational procedures for interpreting radar returns and identifying severe weather cells came directly from the 8th Air Force SWAP program manuals, with Captain Richard Haworth himself leading the training program for commercial operators. Modern aviation weather procedures still reflect lessons written in blood over European skies. The Federal Aviation Administration's Advisory Circular AC 0024C, Thunderstorms, Don't Flirt, Skirt, issued in February 2013, echoes almost verbatim the guidance developed by Colonel Brooks' team in December 1944. The 30-30-30 rule, avoiding thunderstorms by 30 miles, allowing 30 minutes after the last lightning before approach, and considering diversion if thunderstorms cover 30% of terminal area, derives directly from SWAP protocols established in early 1945. The meteorological science itself advanced dramatically through data collected during the war. Dr. Harrison Williams, head of the Weather Research Division at MIT's Radiation Laboratory from 1943-1946, leveraged military weather observations to develop the first comprehensive model of thunderstorm cell formation and life cycle. The bomber crews who flew into clouds gave us invaluable data, often at the cost of their lives, Williams wrote in his 1951 paper Thunderstorm Genesis and Morphology. Their sacrifice allowed us to understand these atmospheric phenomena at a fundamental level, leading directly to modern forecasting capabilities that save countless lives today. The Thunderstorm Project, a joint military-civilian research initiative conducted from 1946-1949, built directly on wartime experience, flying specially equipped B-29 aircraft into thunderstorms to measure conditions that had destroyed so many bombers. Project Director Horace Byers, in his final report, acknowledged the debt owed to wartime crews. Every measurement we take, every data point we record, represents knowledge that might have saved a bomber crew had it been available during the war. Their loss has become our foundation for understanding. At the American Air Museum in Britain, a simple memorial plaque installed in 2003 finally acknowledged this overlooked aspect of the air war. The inscription reads, "In memory of 3,900 American airmen who perished fighting not only a human enemy, but also the implacable physics of atmosphere and weather." Their sacrifice advanced both victory and the science that protects all who fly today. The memorial includes a salvaged artificial horizon from a B-17G that crashed near Woodbridge during a thunderstorm penetration in March 1944. The instrument remains frozen at 70 degrees of bank and 30 degrees nose down, the attitude at impact. The lessons from these losses continue to resonate through aviation today. When a United Airlines pilot diverts hundreds of miles around a line of thunderstorms, when a Delta crew decides to hold rather than approach through developing convective activity, when a FedEx flight cancels rather than depart into questionable conditions, all are implementing protocols developed from the experiences of bomber crews who discovered too late that flying into clouds carried consequences no tactical objective could justify. Weather remains an implacable adversary even in the age of sophisticated radar, satellite imagery, and digital communications. Modern aircraft disappear from radar screens just as B-17s once vanished over the North Sea. The difference is that today's pilots carry the institutional memory of those losses and the procedures developed at such cost. They understand what the bomber crews learned, that the laws of physics cannot be negotiated with, that no schedule is worth a human life, and that sometimes the longest way around is the shortest way home.